Epistasis occurs when an interaction between two different genes causes one gene to mask the effects of another gene. This leads to different genotypes that express the same phenotype. The next slide will show an example of single dominant epistasis to demonstrate how different genotypes can lead to the same phenotype. Two autosomal genes controls the color of flowers. The purple color is controlled by the dominant gene P, and the white color is controlled by the dominant gene W. The pink color appears under the recessive condition little p, little w, little w. Purple is dominant to both white and pink. What ratio of phenotypes appear? To figure out the ratios, we first need to set up the parent generation, which is a purple flower and a white flower that has the genotypes big P, little w, and little p, big W. We would cross this to get the first generation of purple flowers that has the genotype big P, big W, little w, which we would then times by itself to get the second generation and its phenotypic ratios. So this dihybrid cross shows the phenotypes and the genotypes. Okay, so if it has a dominant P gene, even if it has a dominant W gene, the phenotype is going to be purple. If it doesn't have a dominant P gene, but it does have the dominant W gene, then the phenotype is going to be white. And if it doesn't have the dominant P gene, nor does it have the dominant W gene, then the phenotype is going to be pink. And then this gives us the ratio of 12 purple, 3 white, and 1 pink. Another way to get ratios is by using an epistasis pathway. An epistasis pathway uses the ratios from a dihybrid cross that has no epistasis to determine phenotypes. So the ratios are 9 big A, big B to 3 big A, 2 little b's, 3, 2 little a's, 1 big B to 1, 2 little a's, 2 little b's. We can use these ratios to figure out the phenotypes of an organism's offspring. So if we had the parent generation of big A, big B, little b, times big A, big B, little b, we cross that, we would get the first generation of big A, big B, little b, which we would then times by itself to get the second generation and its phenotypic ratios. For this pathway, we're going to use black precursor, a black intermediate, and a gray end product to help us establish ratios. So starting with the 9 big A, big B, you would start at the black precursor. It doesn't have two little a's, but it does have the big A enzyme, so it would move to the black intermediate. Well, it also doesn't have the 2 little b's, and it does have the big B enzyme, so it would move to a gray end product, which means the phenotype would be gray. Next, the 3 big A, 2 little b's. Again, you start at the black precursor. It doesn't have 2 little a's, but it does have the big A enzyme, so it moves to the black intermediate. Well, this does have 2 little b's, which means it can't move to the end product, and it has to stay at the black intermediate, so the phenotype is black. The 3, 2 little a's, and 1 big B. Again, you start at the black precursor. It does have the 2 little a's, which means it cannot move forward, and it has to stay at the black precursor, which means the phenotype is black. The same rule applies to the 2 little a's, 2 b's, so the phenotype is black. This gives us a ratio of 9 gray, 7 black, which is an example of duplicate recessive epistasis. Now, what if we had a parent generation of big A, 2 big B's, and 2 little a's, big B, little b? We would cross this parent generation to get the first generation of big A, big B, little b, which we would then cross by itself to get the second generation and its phenotypic ratios. For this pathway, we're going to have a red precursor, a yellow intermediate, and a white end product to help us establish the ratios. Again, starting with the big A and big B, you start at the red precursor. Doesn't have any little a's, but it does have the enzyme needed, so you move to the yellow intermediate. It does not have any little b's, and it does have the big B enzyme, so it's a white end product. The phenotype is white. The three one big A and two little b's. You start the red precursor. It doesn't have any little a's, but it does have the big A enzyme, which means it moves to the yellow intermediate. Well, this does have two little b's, which means it cannot move forward to the white end product, and it has to stay at the yellow intermediate, which means the phenotype is yellow. The two little a's, one big B. You start the red precursor. Well, this does have two little a's, which means it cannot move forward, and it has to stay at the red precursor. The two little a, two big B. This same rule applies. It has the two little a's, which means it cannot move forward, and it has to stay at the red precursor, so the phenotype is red. And this gives us a phenotypic ratio of 9 white, 3 yellow, 4 red, which is an example of single recessive epistasis. And these are my resources. I used the textbook and the lecture notes.